Factoring trinomials using the rainbow method, example 4. In this example, we'll show how to use the rainbow method for some special cases. The first special case we'll look at is the difference of squares. So our first step is always to write the expression in standard form, ax squared plus bx plus c. But in this case, there's only two terms. The b is missing, so in this case, the b is equal to 0. So we're going to rewrite the expression then as x squared plus 0x minus 16. Now we need to find the a, the b, and the c. The a is going to equal 1, b will equal 0, c will equal 16. We'll multiply the a times c, so 1 times 16 is equal to 16. Now we need to find all the factor pairs for 16, starting with 1 times 16. Next will be 2 times 8, and then 4 times 4. And we found all of the factor pairs. Now we need to link our factor pairs together. We have the 4 and the 4. The next pair will be 2 and 8. And the last pair will be 1 and 16. Now we need to find the sum and difference for each factor pair. We'll have the sums on the top corners and the difference on the lower corners. Starting with 1 and 16, the sum will be 17, and the difference will be 15. For 2 and 8, the sum is 10, and the difference is 6. For 4 and 4, the sum is 8, and the difference is 0. Now we need to locate b and mark the pair that we used. b in this case is 0. Here we have a 0, and we use the 4 and the 4 to form the 0. Now we need to rewrite the expression with this pair. So we write the first term and last term, leave some space in between. Now we're trying to form a 0x, and we're using the 4 and the 4, so we have a plus 4x minus 4x. When combined together gives us the 0x. Now we need to factor by grouping. So we have a first group and second group. From the first group, x squared plus 4x, we can factor in x, leaving us x plus 4. From the second group, we can factor a negative 4, which will leave us an x plus 4. Now we checked inside the parentheses, and both these expressions are identical, so we can continue. And we'll factor out the x plus 4, and that will leave us an x minus 4. So we'll multiply, check our factors using the FOIL. First is the x times x is x squared. Then the outer, x times minus 4, so minus 4x. The inner, plus 4x. And the last, plus 4 minus 4 gives us a negative 16. Combining our like terms, we end up with x squared minus 16, which is the expression we started with. So we did find the factors. The pattern for this special case will be one term squared minus the second term, also squared. And the factors will always be the square root of each term with the sum times the square root of each term with a minus. You can memorize this pattern, or you can just use the rainbow method to find them. The second special case we'll look at will be the sum or difference of terms squared. So for this example, we'll have 25x squared minus 20x plus 4. We'll write our expression in standard form again, ax squared plus bx plus c. We now need to find the a, the b, and the c. So a will be 25, b will be 20, and c will equal 4. We multiply a times c. So we have 25 times 4, which will give us 100. Now we need to find all the factor pairs for 100, starting with 1 times 100. More pairs here, so we need a bit more space. Next we'll have 2 times 50. Then we'll have 4 times 25. Then we'll have 5 times 20. And last we'll have 10 times 10. And we found all the factor pairs for 100. Now we need to link our factor pairs together. So the 10 and the 10 is linked together. The 5 and the 20. Then the 4 and the 25. The 2 and the 50. And the 1 and the 100. Now we need to find the sum and difference for each factor pair. We'll put the sums on the upper corner and the differences on the lower. For 1 and 100, we have 101. The difference is going to be 99. For 2 and 50, we have 52. The difference is 48. For 4 and 25, the sum is 29. The difference is 21. For 5 and 20, we have 25, and the difference is 15. For 10 and 10, we have the sum of 20, and the difference is 0. Now we need to locate B and mark the pair that we used. In this case, B is equal to 20. We have a 20 here on this upper corner, and we use the 10 and the 10 to form the 20. Now we need to rewrite the expression with this pair. So we have the first term and the last term with some space in between. We're trying to form a negative 20x using the 10s. So we have a minus 10x minus 10x. And together combined, they form negative 20x. So that checks good. Now we need to factor by grouping. So we have our first group and second group. From the first group, we could factor out a 5x. That'll leave us a 5x minus 2. From the second group, we can factor a negative 2. And it will leave us a 5x minus 2 again. We check inside the parentheses, and both these expressions are identical. So we factor out a 5x minus 2, and we'll leave us with a 5x minus 2 again. As both these expressions are identical, we can also write them as 5x minus 2 squared. Now let's multiply our factors to check if we got the correct factors. Using our FOIL, first 5x times 5x is 25x squared. Outer, 5x times negative 2 is a negative 10x. Inner, negative 2 times 5x gives us a negative 10x. And last, a negative 2 times negative 2 is a plus 4. Combining our like terms, we have 25x squared minus 20x plus 4. And that was the expression we started with. So we did find the factors. The sum or difference squared is a little more involved to determine if you meet that special case. The first term will be squared and the last term will be squared. And your middle term is a combination of the square root of each of these. If it fits this pattern, then the two factors will be identical with the square root of the first and the last either added or subtracted, and that's squared. As this is a bit more involved to determine if the expression meets this case, as you can see with the rainbow, you don't really need to worry about it. You can just apply the rainbow method and it will find the factors